In this video we'll use Waveform to create this tank. We'll cover how to build the geometry, create the UVs, the animation, and the physics. To begin, we'll first create a new project and call it Tank. In Waveform we build each piece of the model separately, and then at the end we link them all together. We call these separate pieces patterns. So let's first add a pattern for the turret. By default we get this sequence of blocks, and selecting one of them shows us the model that it generates. In this case, a sphere. We create the 3D model from 2D curves. This first curve is the position, then the scale, and then the extrude surface. So we can view the position curve by clicking on this white icon. And we can modify it to see how the 3D model regenerates. The scale curve reuses the same curve as the position. And then the extrude surface is a circle. And this is extruded along the position curve. This extrude iterate block is what actually generates the model. And this final block is what adds physics. We can view the physics by selecting one of the options in this view menu, such as textured and physics bodies, and we can see the sphere. So, to create a turret, we'll first create a cylinder, and to do that we'll edit the position curve and straighten out this line. If we hover over our 3D model, we see that we get these yellow points here, and these are the markers. They correspond to the markers in the 2D view as well. So on our extrude surface we have these 4 points, which match these 4 points at the start, and then it's extruded along again to the second point on the position curve, and we get another 4 points, these yellow points, and then finally another 4 points at the end. These pink points along the center of the model correspond to these 3 points here on the position curve. And finally this grey point in the middle specifies the center. So let's move this back, and we see that we've got a hole in the model, and this is due to backface culling. So we're going to want to seal up this hole. And in order to do that we can change the position curve and drag the first point down back onto the x-axis. We could double click as well to add new points and drag this along, and now we have an interior. We can then keep tweaking this curve until we get what we want. So that is beginning to look like a turret, and we can always come back later and perfect it. So for now we'll move on to another pattern. This one will be the tread, which surround the wheels. And we can think of this as having an extrude surface which is a rectangle, which is then extruded along the position curve, forming the tread. So to turn this into a rectangle we can drag these control points on top of the source points here, and if we hold down shift it will snap to the grid as well. By doing this we form a square, which we can then drag out to form a rectangle. The position curve will then be a joined up shape, so we'll add more points and move these points around. And you can see in the 3D view that we're not getting quite what we want. This is because of these commands here. We specify to only take the x component of each position on this curve. By only taking the x component and ignoring the y and z components, we would end up with just a straight line. And the scale only pays attention to the y components. So that made sense for the sphere, but it doesn't make sense in this case. So we'll add the y component into the y channel. We can see now the position is being extruded along correctly, but the scale isn't quite right yet. And that's because we're reusing this curve, which doesn't make sense again. So we'll remove this, open the toolbox and add a new curve for the scale. We'll then move it up in the y-axis, giving us a constant scale. We can then edit this position curve until we get something more like what we want. We can straighten out the bottom. Add more points in order to make the curve work better. Okay, that looks okay for now. So the next pattern we'll look at is the wheel, but instead of creating it ourselves, we'll import it. Waveform comes with a samples library, and one of those samples is the sports car, which contains the wheel item. We can see that these blocks are the same as what we've seen before, and if we click on one of them we see the wheel that gets generated. But we can see this time the position curve is a different shape, but we're still using the circle for the extrude surface. We've skipped ahead here to a project that already has the patterns complete. So the remaining patterns were the turret base, the tank body, and the bumpers that will go on top of the treads. The next step is to link these patterns together, which we can do by adding a composition. And we'll call this tank. We get this default set of blocks, and this layer block here is known as the base layer. And we'll select the tank body pattern, which we can see comes up in the 3D view, and we'll attach our patterns to this base layer. So let's first duplicate this layer by right clicking and selecting duplicate. Then we will select the tread. We can see it doesn't line up how we'd expect, so we can click on it in the 3D view and we get these options down here: scale, rotate and translate. So if we press S to scale, R to rotate and Y to rotate in the y-axis only, then T to translate, and we can scale it up slightly. To add the tread on the other side, we'll right click, duplicate, and this time we'll open the toolbox and add the mirror option, which will give us a tread on the other side. To add the wheel, we'll do it fully in the 3D view this time, so we can click on a marker on the tread, then press the N key, and we can now cycle through the patterns in the project. So let's find the wheel, left click to make the change permanent, and then we can move this into place again. So two things happened here when we added the wheel. The first is that we added this wheel pattern to this marker on the tread, and that's recorded in the blocks here on the left. So we can see we have the target marker, which is the marker on the base layer, which is the tread, and we have this source marker, which is the marker on the wheel. And these markers are useful because they make the model more robust to change. If we were to change the tread now, we can see that the wheel also moves with the change, because it's just using the markers to line itself up. The other thing that happened was this tread was moved into its own composition, which we can view by clicking on it, and it only contains the tread and the wheel. You can only attach layers to base layers, and as the tread was not a base layer, Waveform pulled it out of the composition and put it in its own. So we can see now the tread is the base layer and the wheel is attached to it. This composition is then referenced in the main composition here. And what's useful about this is we can reuse this composition for the other side. So let's remove this tread, duplicate this composition reference, add the mirror back in, and we can see now we have the tread on both sides with the wheel. If we were to then edit the position of the wheel, we can see that it changes in both sides. The next thing we'll do is we'll add a pattern to the top here, and it will be the turret base. So we'll select the center marker, press the N key, find the turret base, press the left key to make the change permanent. The rotation's wrong, so we'll click on it again, and we can see it's selected the block here on the left. We'll then remove the rotation and scale it down on the right here. We've skipped ahead now to a project that has a complete tank composition. We've also got this other composition which references the tank composition and has this low poly option. And if we select it, we see that the 3D model has less vertices in, and flat shading has also been applied, which gives us this low poly style. This number here, 5, is applied to these numbers here on each pattern, and these numbers specify the degree of change when converting a curve into line segments. A higher degree of change will result in less line segments, meaning less vertices, and a lower degree of change will do the opposite, add more vertices. So the low poly style is achieved by having a higher degree of change. The next thing we will look at is animation. So to begin, we'll add a animation pose item. We'll call it poses. We'll add the low poly model, and we can then select from this list here, which will display a list of bones for this model. So we could select the right tread bumpers and then specify a rotation, and we need to select the fill and wireframe as contours don't animate, and we can see that changing this here rotates the bumper and all of its child bones, which includes the treads and wheels. This hierarchy is created from the composition hierarchy, so in this case we could find this bone by starting at the low poly model, then looking for tank, then looking for the bumper, which in this case was called right tread, and we can see here that we've given this compose a name here in the tag field, right tread. We've also got left tread and top. If we find this compose, auto compose 0, It contains the bumpers pattern. The bumpers pattern then has a position curve which we can view, and if we select the first point, we can see that it has a bone called bone 1. All bones are specified in this curve editor by clicking on a point and just giving it a name. Waveform will then join the bones up as needed. In this case, as there is only one bone, the start position will be the point where the bone name was specified, and the end point will then be the last point. So the bone will be a straight line from start to end. If we go back to this poses now, we can look at how we might rotate a wheel. So let's first select the wheel bone, which would be on the right tread, wheel, bone 1. If we rotate the Y, we can see it moving. So we'll begin by rotating by 120 degrees. We'll duplicate this set of blocks and rotate by 240 degrees, and then we'll duplicate a final time and rotate by 360 degrees, which is back to 0. We can then join these poses together by adding an animation clip and a pose, and selecting the name of the pose, which was poses. We'll duplicate this block and add the next pose, which was animation pose 0, and finally animation pose 1. Now we see the wheel rotating fully. And you can change the timings between interpolation of the poses by changing these values here. We've skipped ahead here now to a project with the animation complete, which we can view by clicking on the animation clip. We can see that we've got all the wheels spinning and also the turret moving too. If we look at the poses workspace, we see that we've got 3 poses where all the wheels are specified, rotating 120 degrees, then 240. We've also got this turret spin, and we've also combined 2 poses here, the none pose and the turret spin. The none pose doesn't contain any blocks, and so when Waveform reaches this pose, it will reset all the bones to their original position, which is 0 degrees on the Y axis for rotation. The spin clip is then again what we've seen already, just combining the 3 poses. The next thing we'll look at now is UVs, which is how we texture the model. To begin, we add a UV item, which is a UV layout, and we get this default block where we can specify the texture that is applied to each pattern. So let's begin by selecting the turret. We'll then want to view textures by selecting a textured option such as textured, and we can see the texture applied to the turret. In this case, the checkerboard has been stretched, and this is because no seams have been added to the model. If we look at the UV map, the 3D turret has been stretched out into this circle, and if we imagine the front of the turret is in the center, these polygons are being stretched across the model, whereas at the back there's less stretching going on, so you can see more of the checkerboard pattern. To fix this, we'll add seams, and to do so we first select the turret pattern, then the extrude surface. We then select one of the points on the curve, and we have this option here, new UV seam. We specify a name such as A. we see that the texture is reapplied with the seam, and we can view the seams by selecting them from the menu option, and we get this red line. So as this surface is extruded along the position curve, each point with the seam A is joined together, forming a straight line. We could add more seams by specifying more names, and you can do this as much as you want. One other thing to cover with seams is maybe we want to split the interior and exterior of the turret, so the interior has its own material. To do this, we would need to split the rim here, which we can't do from this view. We can, however, do it from the position curve, so let's open that up. Select the point on the rim. We then have this UV join ranges input box, and we can specify join a seam up from A to A. So it will start from A, go around each point, and end on A, forming a full circle. For the purpose of this tutorial, we might also want to remove the line inside. We can do this by selecting the point that is the inside of the turret, and then we have this UV enabled checkbox, and if we uncheck it, then no seam is applied at that point. Seams are started once we reach the rim though, which is why we still have this outside line. Finally, to apply a different material to the inside, we'll need to go back to the UV block, and if we view the UV map as it currently is, we see that we have two islands, as we're splitting the turret into two islands, the exterior and the interior, but we only want the checkerboard on the outside. So on this block we have this box here, and we can specify an index of the island that we would like to apply the texture to. No index means all islands. If we say 0, that will choose the first island. We can then duplicate this and specify the second island, which is index 1, and finally we can change the texture, for example to green. Viewing the 3D model again, we'll see that the interior is green. One other thing to cover with UVs is that you can add your own textures. Each project comes with a textures folder, and by dragging any image files into it, they will get picked up by Waveform automatically, and they will appear in this textures drop-down. So we've added army and tread here. There are also other options, such as the emissive, and so on. One other thing to cover with UV maps is that we can change the layout by adding more blocks to the editor here. So for example, the rotation of this island can be modified by changing the UV transform. And we can also add new rows by opening the toolbox and selecting the new grid row option. And usually with a UV map you want the dimensions to match up as close as possible. So that is why we might edit the UV map in this way. We've skipped ahead here now to a project that has all these seams added in, which we can see here with the red lines. We've also completed the UV map, which we can view by selecting the textured option and selecting the UV map. And we've applied this army texture as well as the tread texture to the treads. We turn off the UV seams for the moment, and we view the UV map. We can see that we've added 3 rows for all the patterns. We've also got this other thing that we haven't referenced here, which is a nested UV layout. So the nested UV layout can be seen here on the left, and this contains 3 of its own rows. This layout is then referenced with this block here in the main layout. This is useful again for compacting islands, and in this case it made sense to compact all the small islands into their own layout and then reference it and put it on the second row. The final thing we'll now cover is physics. So to view the physics, we'll first select a physics option such as textured and physics bodies, and we can see that by default Waveform has added spheres to each pattern. If we look at the turret pattern, we've got this sphere collider block, and it's added this orange sphere here. This isn't really doing very much, so we'll remove it for now. Then we'll move on to the turret base, and we'll probably want a physics body for this one, so we'll switch to the box, as that will give a better fit. We'll do the same with the tank body. We can see we've got spheres for the wheels, which we'll remove as well. We'll also remove the body from the tread. And finally, for the bumpers, we'll specify capsules. And in order to make these capsules contain the whole tread, we'll scale them up ourselves, which we can do from here. We'll select the UV again so that it's shown. We notice that the capsule length is too long, so let's remove the Y component from our scale, which is the length. We notice that it could still be scaled down further, so let's duplicate this, add the Y component, and then scale it down to something like 0.6. We could then scale this up slightly, and now that fits. The physics bodies don't have to be completely accurate in order to give a good result, and we can view how they interact by turning on the simulation from the menu. And the grid is a physics floor, so it will interact with that, and we can click and drag with the mouse to throw the model around. By default, Waveform will add loose joints between the rigid bodies, depending on the bone hierarchy, and when we import this model into a game engine, we might instead choose fixed joints, which would make more sense for a tank. The final thing we'll cover is exporting the model. To do this, we'll add an export item, and we'll call it export. We then get this form, and the file path by default is the export folder, which is in the project folder, and the file is called tank. We can select the process to export, which is any of the patterns or compositions in the project, and in this case we'll select low poly. We can also choose which UV map to use, and select or deselect any of the animations. We can also modify the cull mode and polygon format, as well as the file format. Finally, to export, we click the export button. By selecting the FBX file format, we'll also export the bones, which will export the animations as well. It will also export the physics as they're attached to the bones, and that will be placed in a separate file. If you download the Unity project from the website, that contains an editor script which will import the physics file along with the FBX file, and it will set it up to work with the colliders and rigid bodies in Unity for you. That concludes this tutorial video. Hopefully this has given you an insight into how Waveform can save you time when creating 3D models, and because of its flexible structure, you can edit any of the part of the process at any time, and the geometry, UVs, animation, and physics will regenerate to fit. You can download a free 30-day trial copy today by following the link in the description. Thank you for watching.